4. Values of trig functions. On the unit circle, we have sine and cosine as the x and the y. Sine of theta. X and y. On the unit circle, the hypotenuse is equal to 1. All right? However, on the unit circle is not a function. It doesn't pass the vertical line test. We talked about theta in radians, and we talked about how to graph things out as a function. So, when we talk about a reference angle, if I tell you theta is 300 degrees, on the unit circle, well, that'd be the 4th quadrant. All the reference angles go to the x-axis, so that would be 60 degrees is the reference angle. All reference angles are between 90 and 0, and they have to be positive. For radians, they have to be from pi over 2 to 0. Do you know what pi over 2 is as a decimal? You have a calculator? What is pi over 2 as a decimal? 1.57? All right, so now, you know if they ask for a reference angle, you know what it has to be in terms of degrees. You know what it has to be in terms of exact values. And you know what it has to be in terms of as far as real numbers. So you're ready for any angle I give you to give me the reference angle. If you have a reference angle, you have a reference triangle. If you have a reference triangle, you can find exact values of trig functions. For instance, if I go around the circle 4 degrees, this would be 90, this would be 180, this would be 270, and 360. And I'm starting at 0. In radians, it would go 0, pi over 2, pi, 3 pi over 2, and 2 pi. So far, so good. We all know those facts to be true. Now, in terms of real numbers, without the pi, what is still 0? That's good. This is 1.57. This is 3.14. What is 3 pi over 2 as a decimal? You have a calculator. 4.7. And then finally, 6.28. You have all those numbers because if I say what is the reference angle for theta if theta equals 5? It's not 5 degrees. Pi is already in there. This is one of those real numbers. Your answer is going to be between 0 and 1.57. We said you always draw it to the x-axis. The problem is, which quadrant does 5 terminate in? The 4th. It goes past 4.7 to 5. So how can you find the reference angle from here to there? How can you find how far this is? Yeah, 6.28 minus 5. That gives you 1.72. That is your reference angle, 1.72. Okay? So based on the angle, you can find the reference angle using either the red, the blue, or the black, based on how the number's given. Was it? Oh yeah, 1.28, sorry. Sorry, 1.28. Somebody else said 1.72, my fault. 1.28. Quiet, please. All right, here we go. So on this one, it always goes to the x-axis, it's always positive. Yep.
So you add 1.28 to 4.7.
And it gives you 6.28. Okay. So 165. Which quadrant is this in? Yeah, second quadrant. So the question is, what is the reference angle? 15 degrees. On that one, you took 180 minus 165 and got the 15. Okay? So 275. Which quadrant would it be in? I think it goes past 270, doesn't it? Okay? So this one is past it. So to get to the x-axis and stay between 0 and 90, right, you got to take 360 minus 275, and you get 85 degrees. All right? It matters whether you have to add or subtract 180 or 360, depending on where you're at as far as the angle. Negative 110, which quadrant does that go to? The third. So I go to negative 110 right here. To find the reference angle, I have to go up there. How far is it? 70. So 180 minus 110, 70 degrees. That's the reference angle. Reference. And 400. This one was a little bit confusing second hour.
Doesn't it go all the way around?
It does go all the way around. All the way back to 360, then how far does it go? 40. So the question is, how far is the terminal side to the x-axis? Close. You always use the x-axis. So it'd be 40. It'd be 40 minus 0, or 40. Theta reference angle equals 40 degrees. Because you're 40 degrees past 0, or 40 minus 0. It always has to stay positive. Okay? The hardest one, and I'll be honest, is the radians. Trying to work that one out. For instance, on number 6, these are all radians. You have your notes in front of you. You know at 0, 1.57, 3.14, 6.28, and what was this, 4 point what?
4.7.
4.7. So, when I say 6, how far is the reference angle?
Good game tonight.
Sure, I hope.
Hey, remember those 3 little response things that you left with me in the summer?
Yeah?
Do you have those damaged ones?
Yeah, I think so. Okay.
I just want to make sure. Get them later, okay?
Well, I got them right here.
They want them back. Unless you want to keep them, okay?
No. All right. Those are the.
There's 2 of them.
I think these are the ones I kept.
Yeah, those look new.
Check the numbers on those. Okay. I think those are it. Because I haven't got them out yet. Yeah, no problem. All right.
That one's 0.28.
It is. The reference angle is 0.28. So, Emily, what about negative 4? She is a chit-chatter.
3.28?
I don't think so.
Would it be 0.7?
6.28 minus 4. So 2.28.
No. Look, if I have negative 1.57, if I have 0, negative 3.14, negative 4.7, if I go all the way to here,
So it'd be negative.
so I have to go back to this way.
Why would you do that?
Well, because it says negative 4.
Okay, go positive.
So I'm going in a negative direction up to here. And I always go back to the x-axis because that's how I draw my right triangles. Right angle is always the x-axis. Central angle is always next to the origin. And when I draw this down, I have to take 4 minus 3.14.
Isn't it closer to 4.7?
It is, but you always go to the x-axis because you always draw your right triangle to the x-axis. So it should be the reference angle for negative 4 should be 0.86, right? That's the reference angle. What about C? $4.5.
No.
Well, I'd use this one. 4.5, I'm right here. So I have to go back to the x-axis. So I'm going to subtract 3.14. So I get 1.36 as my reference angle. 80. Well, if each lap is 6.28, how many laps is that? It's 12.74 laps, right? So how many radians is 0.74 of a lap? 0.74 of 2 pi is how much? So it's 12 revolutions. So 0.74 times 2 pi is what? What is it? What is it? Is that what you got to do? 4.65? All right. Hey, wait a minute. Does that end? Oh, just short of 4.7.
7.4 is 2 pi mean.
Oh, we got 80 divided by 6.28 is 12.74. So that means 0.74 of 28 gives me the leftover radian angle measure. Oh, I multiplied those two numbers together. That's what of means. You multiply. Okay. So it is right here, just short of 4.7. Yeah, you minus 3.14, what do you get? 1 point what? 5.1. Fantastic.
What about the 12 though?
No, moving on.
What about the 12?
Whoa.
What do you do with the 12?
Nothing, because you go around 12 times.
Oh, and then what's left over?
Right, then we went 4.65 right here. So we took 12 laps and ended right there. All right? It's kind of like me playing tetherball against somebody. You know, I just keep going around them. You'd be like Firkins. You know, and then boom, game over.
I've never played a ball.
I know you'd lose. All right, go ahead.
I heard that you got your class today.
I didn't hear a word she said.
You kicked the kid out of class.
Why are you so obsessed with
More than one. I kicked 3 out, if you want to be honest.
Okay, but who said that today's math actually
Caleb and Lonnie?
Good.
Yeah.
All right, here we go. Sine of 210. Firkins,
Ready?
where's 210 at?
Third quadrant.
Would be in the third quadrant.
What's the reference angle for 210?
The reference angle for 210 would probably be, pi of 6.
Is that right?
7 pi over 6, sorry. Taylor.
Dude,
Taylor did not.
do you see a degree symbol there?
330. 30.
30 degrees.
Yeah, I learned that on Taylor.
210 is theta.
You made it.
Reference angle, 30 degrees. Right angle, this way, Chad. Chad, this way, there you go. Now, on the 30, 60, 90, 30, 60, 90, this is the short leg, this is the long leg, and this is the hypotenuse. So we have -1/2, oh sorry, just 1. We have -1, we have 2, we have negative square root of 3. So what's the sign of that going to be? Yeah, opposite of hypotenuse, so it'll be -1/2. Some people will just go to the unit circle.
I just think you just go to the unit circle.
Oh yeah, but don't forget, on your unit circle, you won't have that out for your test. Some people are making allowances for, okay, if I don't remember this is negative square root of 3 over 2, -1/2, is there another way I can do it? This is the other way with the reference triangles.
Oh, wait.
What? If you want to draw it first before you take it, I think that'd be great, but actually, no, you can't bring one in already done. Okay?
Attention. Phone's ringing. Your phone is just ringing. I'm not even kidding.
There it is again. All right, sine of -315. Sine. Oh, even an odd property.
Against you, son.
No.
What is your wife?
Hope it's not. Sine -315. Even an odd property. Thomas. Sine of negative theta. How do I rewrite that? Sine of negative theta is it even or odd?
Odd.
So I take the negative sine of theta. So I take the negative sine of 3/15. So DVP, what is?
Why do you do that?
Oh, sorry, my fault. We changed it to positive. What is the reference angle for 3/15?
Um, 45.
Good. And we have 45 right here. So we have 1, 1, this is negative square root of 2. And opposite over hypotenuse. So I have the negative of negative 1 over square root of 2. So the final answer will be square root of 2 over 2. You can also look on your unit circle and use the y coordinate, and you could have taken the opposite of it, square root of 2 over 2. Okay? Either way, with the reference circle, with the even and the odd, and with the triangle.
3 squared or 2.
So do you only
Yep.
want them to be 45, 45, or 36?
Yep, they will be if it's exact value. If it's not exact value, you can use your calculator. All right?
What's up with the whole negative sign?
Oh, I don't like working with negative angles, so I always use the even and the odd properties to rewrite them. Sometimes the negative goes out in front, sometimes the negative goes away. Moving on. Exact value. 5 pi over 4. Which quadrant is that going to be in? Third. And what's the reference arc for there? It's just pi over 4, isn't it? Radians are easy. Just pi over 3, pi over 4, pi over 6. So that gives you your... And what's the definition of cosine, Jeremy?
Negative root 2 over 2.
Good. So the answer will be right negative root 2 over 2 because it's going to be adjacent over hypotenuse. Or you got the unit circle. Either way. Some people actually learn both ways. They use 45, 45, 90s off the unit circle, 30, 60, 90s off the short, long legs. So it changes. Negative 11 pi over 6. This goes back to the even and the odd again. What's cosine, even or odd? Even. So I can just go to cosine of 11 pi over 6, and the negative will drop. Turns to a positive. Very good. It'll be right here. You can either use the unit circle and get root 3 over 2, or you can use your reference angle, and then you have adjacent over hypotenuse. Okay, either way. All right. Questions?
So we can drop this in the circle.
Sure. Yep. In fact, some people, this one year, this one class, they'd come in and I said, test is out. And as soon as the test was out, they all started drawing the unit circle. And I told you that's what you do in college, right? As soon as the test is out, you get that blank sheet of paper, you start writing down your formulas. Well, they came in, started writing down the unit circle. They wrote it down first. Most of them only did one quadrant. You know, if you got one quadrant, I think you got pretty much the whole thing, don't you? Some people think you do. So anyway, they wrote down one quadrant and they took off. Wrote down a few identities, you know, the Pythagorean identities, and they took off and took their test. The test is going to be very comprehensive. I wrote it for 5th hour. It's going to be fun. Exact value. I like these. These are secants and cosecants. We're almost to the point where we can take a brain break after a couple more slides. I got to get to a certain point today. I can't let Perkins slow me down.
Oh, we're ending on a brain break. It really just stops now.
Quiet, please, Cameron. We're this way. Cameron, what's the definition of secant? Cameron, definition of secant? 1 over x. So Cameron would go to the unit circle. I probably wouldn't, but I probably know that my reference angle is 45. I get that triangle. I know that secant is hypotenuse over adjacent. So what would that be?
3 squared 2 over 1, so
Yeah.
square root 2.
Right, so equal negative square root of 2. The reason I do that is, if I go to the unit circle and I have to take 1 over negative square root of 2 over 2, that doesn't sound a whole lot of fun to me. You know, taking 1 over that fraction and rationalizing all that other stuff. So for some of them, I just take the easy route. And for secants and cosines, or secants and cosecants, I might use reference triangles all the time.
Wouldn't it be negative root 2 root 2?
No, that'd be the cosine. This is secant. All right.
Negative root 2.
That's your answer, negative root 2. All right, Jared, secant of negative 210. How do I rewrite that using the even and the odd properties? Very good, secant of 210. All right, what is your reference angle for 210 going to be? If that's 210, what's the reference angle? Yeah, it's 30 degrees right here. Well, there you go again. Negative 1, root 3, and 2. Negative root 3. You can use that reference triangle, or you can use the x-coordinate of the unit circle. Makes no difference to me. Some people are all reference triangles. What is the secant of 210 then on your answer? Let's see, Rachel, what'd you get? That would be for cosecant. I think for secant is hypotenuse over adjacent. Yeah. Negative 2 root 3 over 3. Yeah. Correct. So I dropped the negative to a positive angle. Doesn't affect the ratios, just affects the
Can
angles.
you just look at your, like, the unit circle and flip it?
Yep.
I'd start learning already.
What?
Yeah, no.
Nothing.
You're trying to what?
Chit chat, something.
I
Yeah.
just memorize it.
What?
Actually, no.
How far past 210 of 180 is it?
Oh,
You always go either to 180 or 360. Okay? You always go back to the x-axis. Aha! There's a calculator questions. All right. This is very simple. You ask yourself, do I see a degree sign?
Yep.
Then you're in degree mode. If you don't, you're in radian mode. Thankful for you, you've only got 2 modes on your calculator, degrees and radians. I wouldn't type it out. I would type it out like this, cosine parentheses 38 plus 30 over 60.
It's the same thing as by that thing on top.
Yep, or you can type out cosine of 30, go to apps, angle, get a little degree, make sure you got parentheses right here, 38 degrees and 30 minutes. Same thing. I'm not one for a whole lot of fluff, but some people like to take the extra keystrokes. I don't. And what do you get? What is it? 0.78. 0.78, right? Did you know that if I went to the first quadrant of the unit circle, do a triangle, and the angle measured 38 degrees and 30 minutes? (38 degrees, 30 minutes). Did you know that the adjacent side would be 0.78 and the hypotenuse would be 1 because the definition of cosine is adjacent over hypotenuse? That's what it means. The ratio, 0.78, hypotenuse would be 1. You can also figure out the sine if you wanted to,
How would it be 1?
because you can put any number over 1 and the adjacent side is less than the hypotenuse. Okay? Well, that's sine of 1.48. Do you see a degree sign? That means you are in radians. What is it? 0.996. That's the sine of 1.48. Now my question is, Which quadrant is 1.48 in? Which quadrant? First. So if you drew and you had the arc length of 1.48, the opposite side would be 0.996, hypotenuse would be 1. You can put any number you want over 1 and write it using your trig ratios. This is a hypotenuse over opposite over hypotenuse. We're almost there. Ready? Here we go. You have your note card to remember how to do this so you can learn it for the test. What identity do you know is true about cosecant? Burn. Cosecant is equal to what? Oh, pay attention. When I ask somebody a question, I focus on them. I don't even notice it's sleeting or snowing outside. Good, 1 over sine. Our type it is 43 plus 40 over 60. And I'd be in what mode?
Degrees.
Degree mode. What? What is it? 1.45? That means if I was at 43 degrees in 40 minutes, watch very carefully. Anyway, if I put this over 1, is 1.45 the opposite side of the hypotenuse? No. What's the definition of cosecant? Hypotenuse over opposite. Longest side is 1.45. The opposite side is 1.
But wouldn't that be the wouldn't the 1.45
Why
be your
am I not
hypotenuse?
getting that?
It would be. I just labeled it hypotenuse.
I'm getting like 0.6. Yeah, that's what
Are you?
All right, Beamer, give it here.
Your degrees?
Give it here, Beamer.
Yeah, it's 1 divided by.
1 divided by sine 43 plus 40 divided by 60. Woo-hoo! Here you go. All right, Perkins. Secant 0.26.
Sequent is 1 over cosine. So, yeah, switching back to radians.
Yep.
So everybody should do that.
So wait, why is it 1.5?
Because definition is hypotenuse over the opposite side. All right, what'd you get for this one? 1.03. That means if you went up 0.26 radians, the length from here to here would be 1.03 or would it be 1? 1.03 and the adjacent side would be 1. Okay? Fantastic. So, your homework is on what page? And after this, we're going to do a brain break. Page 414, 1 through 25 odd. Okay? So far, so good? 24 is not odd there, Nagy.
I was